Let's go over the chi-square test. Before I start, I'm an AP biology teacher, and this is for an AP bio class, not really a statistics class. Your stats teacher might explain this a little bit more in depth than I will. But basically, chi-square is an equation to analyze if differences in data are due to chance or a variable being tested. X squared is going to represent chi-square, and this is the equation to calculate that number. Now, I'm not going to go over the steps to calculate this equation. I'm going to do that in another video. I just want to go over the concept behind this chi-square. Basically, you're comparing the observed results with the expected results. In some data set, we expect to get certain numbers. However, we don't always get those expected numbers. These observed values aren't always going to be exactly like expected. So what we have to do is we have to figure out if there is a variable that's changing the outcome. And to do that, we use the chi-square test. After you figure out the chi-square, you have to use it using a chi-square table. This is a reference table that lists all the chi-square critical values. On the left-hand side of this chi-square table are the degrees of freedom. On the right side here in this group are critical values. On the top are your p-values. For AP Biology, we use the p-value of 0.05. So again, these chi-square tables help us find our critical values that's going to help us find whether our p-value is larger or smaller than 0.05. When we find that critical value, we compare it with the chi-square value. And then we can either reject or fail to reject our null hypothesis. However, to figure out which line or which degree of freedom we're on, we have to look at the number of outcomes in our test. To figure out which degree of freedom we're on, we're going to take the number of outcomes minus 1. So let's say there are 6 outcomes. We take 6 minus 1, which means we're going to be on the 5th line. So we go to our 5th line and we find our critical value, which is 11.070. What we do is we use the chi-square value and compare it with that 11.070, which is the critical value. In this specific case, if the chi-square is smaller than 11.070, then we're going to fail to reject the null hypothesis. That's because it falls onto the left side here of our chi-square table, or to the left of the critical value. If that chi-square value is to the right here or is larger than 11.070, we're going to reject the null hypothesis. That's because the chi-square will tell us whether or not our p-value is going to be larger or smaller than 0.05. If it's smaller than 0.05, we reject the null hypothesis. If it's larger, then we fail to reject our null hypothesis.